Students, welcome back to all 4 C-learning classes. Dear students, we have started divisibility problems in binomial theorem. Let us continue the problems in divisibility. Okay? Please observe these points. Suppose n is any integer. That means 1, 2, 3, so on up to infinite, any integer. This value is divided with 4. Then what are the possible remainders? Suppose the number is 100. 100 is divided with 4. What is the remainder? 25 times cancel 0. Remainder is 0. Suppose the number is 101. What is the remainder? 1. 102. Remainder is 2. 103. Remainder is 3. 104. Again remainder is 0. The possible values of the remainders are 0, 1, 2, 3. Okay. Suppose the number is divided with 5. What are the possible remainders? 0, 1, 2, 3, 4. Suppose the number is divided with 6. What are the possible remainders? 0, 1, 2, 3, 4, 5. Okay. Please observe these values. Okay. Next. If it is divided with 4, then the remainder is 0. When it is remainder is 0, the number is completely divisible by 4, then the remainder is 0. That means the number is in the form of 4k form, where k belongs to any integer. 4k form. 4 into 1, 4 into 2, 4 into 3, 4 into 100, 4 into 150. Any value divisible by 4. That means remainder is 0. Suppose the number is in this form, 4k plus 1. What is the remainder? 4k is divisible by 4. So, here remainder 0 plus 1. That means remainder is 1. If the number is in the form of 4k plus 2, what is the remainder? 2. If the number is in the form of 4k plus 3, remainder is 3. Okay. If the number is in the form of 5k, if it is divided with 5, what is the remainder? 0. 5k plus 1, remainder is 1. 5k plus 2, remainder is 2. 5k plus 3, remainder is 3. 5k plus 4, remainder is 4. Suppose the number is in this form, 5k minus 1. Or 4k minus 1. In this case, remainder is not equal to minus 1. Remainder never be negative. 0, 1, 2, 3. If the number is 4, the possible values are 0, 1, 2, 3. If the number is 5, the possible values are 0, 1, 2, 3, 4. Never be negative. That means, here, we can reduce this value into 5 into k minus 1 plus 5 minus 1. 5 into k minus 1 means it is integer into 5 means it is divisible by 5. 5 minus 1 means remainder is 4. If there is a negative term, to get the remainder, 5 minus 1. That is equal to 4. Suppose it is divided with, suppose 7k minus 1. It is divided with 7. What is the remainder? 7 minus 1. That means 6. Okay. Please observe these values and note these values. First one. Let n be a positive integer and it is divided with 5. And it is divided with 5. Then remainder is 0 or 1 or 2 or 3 or 4. Negative values are never be occurs. Okay. Next. Remainder is equal to 0 when n is equal to divided with 5. So it is in the form of 5k. Remainder 0 when n is equal to 5k form. That means k belongs to n. Next. Remainder is equal to 1 when n is equal to capital N. Capital N is equal to 5k plus 1. 5k plus 2, remainder is equal to. Please write all possible values. Remainder is equal to 3. Remainder is equal to 4. When it is in the form of 5k plus 3. When it is in the form of 5k plus 4. Okay. Second one. If n is equal to 5k minus 1 form, then what is the remainder? Remainder is equal to 5 minus 1, that is equal to 4. Remainder never be occurs negative. So that means 5 minus 1, that is equal to 4. Please observe this value. Next, if the number is in this form, 5k minus 2. What is the remainder? 5 minus 2. Number is in the form of 5k minus 3. Next, 5k minus 4. Please write these values. In this case, remainder is 5 minus 2, that is equal to 3. In this case, remainder is 5 minus 3, 2. In this case, remainder is 5 minus 4, that is equal to 1. If the number is 5k, remainder is always, it is divisible by 5. So, remainder is 0. Okay. Next, third one. Third point. This value. If n is equal to 5k form, then what is the fractional part of n by 5? If it is divided with n by 5, That means that is equal to fractional part of 5k by 5 means 5 cancel. K is integer. Here k must be integer. Integral part of k, fractional part of k is nothing but fractional part of integer is nothing but 0. Okay. Next, fractional part of 5k plus 1. If it is in the form of 5k plus 5, after splitting it can be reduced into k plus 1 by 5. Here it is integer. Integral fractional part of k plus some f is nothing but f, fractional part. Here does not depends upon this integer. Okay, please observe that points. Next point, please note this value. Third one. If n is equal to 5k, then fractional part of n by 5 is equal to 0. Okay. If n is equal to 5k plus 1 form, then fractional part of n by 5 is equal to, fractional part depends upon 5k by 5 means k plus 1 by 5. That means 1 by 5. That means remainder by 5. Please observe that point. Remainder by 5. Okay. Next, n is equal to 5k plus 2. What is the fractional part? 2 by 5. If n is equal to 5k plus 3, what is the fractional part? N is equal to 5k plus 4. The fractional part is here 3 by 5, here 4 by 5, where this represents fractional part of x. Okay. Suppose the question is in this way, 5k minus 1. What is the fractional part? 5k minus 1 means 5 into k minus 1 plus 4. That means fractional part is 4 by 5. Please observe that value. Fraction part of x is always greater than or equal to 0. This value lies in between 0 to 1. This value never be negative. Okay. That means in this case also we take the remainder by that 5. Okay. Please observe this value. Next, if n is equal to 5k minus 1, then fractional part of n by 5 is equal dash. That means 4 by 5. 5k minus 2, 5k minus 3, 5k minus 4. Please note these values. Next, let k be any positive integer. K be any positive integer. The last digit in k into 10. Suppose 105, it is one of the number. 105 into 10. What is this value? 1050. Last digit in this number is 0. Okay. If let k be the any positive integer, then the last digit in k into 10. K into 10. K into 10 means this integer into 10 means last digit means units place. That value is equal to always 0. Okay. Suppose the question is in this way. K into 10 plus 1. Here last digit always 0. Here plus 1. By adding 1 we get what is the last digit depends upon this value only. So the last digit is 1. Okay. Similarly, k into 10 plus 2. What is the last digit or units place digit? 2. Next, k into 10 plus 3. Last digit is 3. Okay. Please note this value. Let k be the any positive integer. Then the last digit in k into 10 is 0. The last digit in k into 10 plus 1 is 1. The last digit in k into 10 plus 2 is, what is that value? 2. Okay. 3. So on. Suppose in the same way, the last digit in k into 10 square. Suppose this number is 239 into 10 square. 10 square means 23900. Here the last two digits must be 00. Okay. Please note this value also. The last two digits in k into 10 square is 00. Okay. Next, the last two digits in k into 10 square plus, suppose this value is 23. Depends, last two digits are always 0 in this case. So that value depends upon only this 23. That means 23. Okay. K into 10 square plus 57. What are the last digits? Does not depends upon this value, 57. Please note this value. In the same way, the last three digits in k into 10 cube. K into 10 cube. So say that value is 259 into 10 cube means the last three digits must be 0. Last three digits 0. In this case, last digits always 0. Plus you add something value. That means that value last 3 digits depends upon this number only. Okay, in this case also, please write that values. The last 3 digits in k into 10 cube is 0, 0, 0. The last 3 digits in k into 10 cube plus x, y, z. What are the last digits? X, y, z. Where x value lies in between 0 to 9, y value lies in between 0 to 9, z value lies in between 0 to 9. Here 0 less than or equal to x comma y comma z less than or equal to 9. Every digit value we take from 0 to 9 only. Okay now. Next, please note this value. Similarly, in 4 digit numbers, k into 10 power 4, last 4 digits are 0. K into 10 power 5, last 5 digits are 0. Okay, please note these values. Next, write some examples. The number 9 power 11 plus 11 power 9 is divisible by dash. The number 9 power 11 plus 11 power 9 is divisible by dash. Here base is 9, here base is 11. We can reduce these values in this way. 9 means 10 minus 1, 11 means 10 plus 1. Okay, 9 means 10 minus 1, here 10 plus 1. That means 9 means 10 minus 1 whole power 11 plus 10 plus 1 whole power 9. Please observe this value. 10 minus 1 whole power 11 plus 10 plus 1 whole power 9. Suppose we take minus is the common term, minus of 1 minus 10 whole power 11. Whole power 11. Okay, that means minus of 1 minus 10 whole power 11. Minus of some odd number means minus, plus 1 plus 10 whole power 9. It is in the form of 1 plus x whole power n and 1 minus x whole power n. 1 plus x whole power n means c0 plus c1x plus c2x square plus so on cn into x power n. 1 minus x whole power n means c0 minus c1x plus c2x square so on. By expanding this value, minus of 11c0 minus 11c1 into 10 plus 11c2 into 10 square minus 11c3 into 10 cube so on. What is the last term? Plus minus 1 whole power 11. That means minus into 11c11 into what is that value? 10 power 11. Okay. Plus 1 plus 10 whole power 9 means 9c0 plus 9c1 into 10 plus 9c2 into 10 square plus so on 9c9 into 10 power 9. Please observe these values. Okay. Here, what is the value of 11c0? 1. What is the value of 9c0? 9c0 means 1. Here, minus of 11c0 means minus 1 plus 1. These two are cancelled. These two are cancelled. Minus into minus means plus. Plus 11c1 into 10. Please observe these values. Minus 11c, minus of minus plus. 11c1 into 10 means that value is equal to, minus of minus 110 plus here, what is that value? 90. 110 plus 90 means 200 plus in all the remaining cases, please observe these values. In all the remaining cases, 10 square into something, 10 cube into something. What is the common term here? 10 square. In all the remaining these values also, what is the common term? 10 square plus 10 square into some values. That means all of these values are integer. 10 square into some integer. 10 square into some integer. Okay. 10 square into some integer. That means 200 plus 100 into some integer. What is the common term? 100 into 2 plus some integer. Okay. 100 into 2 plus some integer means this value is always divisible by 100. This value is always divisible by 100 into integer. 8 into integer, that value is divisible by 8. Okay, 16 into integer, that value must be divisible by 16. So, this value is divisible by, what is that value? 100. Suppose, in a single correct answers in this way, that it is divisible by option A, 10, option B, 20, option C, 30, option D, 100. In single correct answer, what is the correct answer? D is the correct answer. In multiple options, if this number is divisible by 100, what are the factors of 100? All the factors are divisible by all these factors. 2, 4, 5, next 10, next 20, next 25, next 50. All of these are the factors of this value. If the number is divisible by 100, that number must be divisible by 2, 4, 5, all of these values. In a multiple options, all of these are correct. Out of these, which is more, that value is the single correct answer. Single correct answer, we take greatest value. In a multiple options, all the factors are also, the number is divisible by all the factors of this number. Please observe this point. Very, very, very important. Okay. In this case, this is divisible by 100. Okay. Please note that value. Next, second one. Second one. The remainder, when 3 power 113 is divided by 13. It is divided with 13. In this case, we find the remainder, it is divided with 13. When we divided with 5, the base can be converted into a 5 or multiples of 5. Suppose this value is divided with 13, we can convert the base value into 13 or multiples of 13. That is very, very, very important. Okay, in this case, the given value is 3 power 113, but here 3 is the prime and 13 is the prime, 13 is the prime. We cannot convert into in terms of 13. So what are the possibilities? Multiples of 13. So 3 means 3, 3 power 1 means 3, 3 square means 9, 3 cube means, what is the meaning of 3 cube? 27. This 27 can be converted into 1 plus 26. Here 26 is the multiple of 13. That means 26 by 13 means it is completely divisible by 13. 26 cube, all of these are divisible by 13. So first we reduce the base into 13 or 13 multiples. If possible, you convert into 13. Otherwise, you convert into multiples of 13. That is very, very important. Okay. So 3 cube means 27. 27 can be converted into 1 plus 26. Okay. Here we convert into 3 cube. 3 cube means 113 is not a multiple of 3. 3 into something. 1 plus 3. 5. 5 is not divisible by 3. So we convert this value into divisible by 3 first. Here 113 can be reduced into 3 power 3 square into 3 power 111. Please observe this value. 3 square into 3 power 111. Okay. 1111 is divisible by 111 is divisible by 3. So it can be reduced into 3 square means 9 into 3 cube whole power 3 cube whole power 3 3 is 9, 7 3 is 21. Is it correct or not? Okay. 3 cube means 27. 9 into 27 whole power 37. It can be reduced into 9 into, please observe this value, 1 plus 26 whole power 37. It is in the form of 1 plus x whole power n. What is the formula for 1 plus x whole power n? C0 plus C1x plus 1. 9 into, okay, 37 C0 plus 37 C1 into 26 plus 37 C2 into 26 square plus so on infinite, so on 37 C37. Okay. In this case, what is this value? 1. It is the 26 square. Here, what is the common term out of these all values? 26 is the common term. That is equal to 9 into 1 plus 26 is the common term into some integral values. It is some k form. 26 into k means this value is always divisible by 13. Here remainder is 0. So this term is in the form of 9 plus 26 into 9 into k. That means 26 into some integer, 9 into integer. This value is always integer. So this value divisible by 13. What is the remainder? What is the remainder? The remainder is nothing but 9. Please observe this value, very, very important. That is equal to 26 into 9 into integer plus 9. 26 means 13 into 2. That means 13 into some p plus 9. 13 into some integer plus 9. If we divided with 5, if it is in the form of 5k plus 1, what is the remainder? 1 is the remainder. 5k plus 2, what is the remainder? 2. 5k plus 3. Okay. In this case, 13 into p plus 9. 13k plus 1 form. So, remainder is 9. Very, very, very important. Okay. Please note that value. Next. Third one. Find the remainder when 6 power 83 plus 8 power 83 is divided by 49. Divided by 49. In this case, this value can be reduced into 49 into some integer plus 1 or plus 2 or so on plus 48. If the number can be reduced in this form, what is the remainder? 1. In this case 2. In this case 48. Okay. So this value can be reduced into 49 into some integer plus constant. That k value lies in the interval 0 to 48. Okay. Please note this value. 6 power 83 plus 8 power 83. Here in this case we divided with 49. 49 means here 6 means 7 minus 1. Okay. 8 means 7 plus 1. 7 square means 49. Okay, 7 square means 49. 7 square term contains 49. 7 cube term contains 49. 7 power 4. So, in the terms if we common 7 square, that number, total number is divisible by 49. So, the remaining part depends upon, the remainder depends upon the remaining part. Okay, please note this value. 6 power 83, that means 7 minus 1 whole power 83 plus 7 plus 1 whole power 83. Okay, this means minus of 1 minus 7 whole power 83. That means that minus of 1 minus 7 whole power 83 plus 1 plus 7 whole power 83. That is equal to 1 plus 7 whole power 83 minus 1 minus 7 whole power 83. Expand this value. What is this value? 83 C0 plus 83 C1 into 7, 83 C2 into 7 square plus so on, 83 C83 7 power 83 minus 83 C0, okay, minus 83 C1 into 7 plus 83 C2 into 7 square minus so on dash dash dash. Please observe these values. In this case 83 C1, 83 C1 cancel, minus of minus these values plus. Here 83 C2 square, 83 C2 square cancel. Next 83 C cube is appeared. That means 2 of, after reducing this value, it can be reduced into, what is that value? 2 of, please observe this value, 83 C1 into 7, okay, plus 83 C1 into 7 plus 83 C1 into 7, that means 2 of, okay. Next 83 C3 into 7 cube plus so on. Okay, here 83 C3 into 7 cube 7 power 5. In this case, what is the common term? 7 square is the common term. 7 square into some integer. This value always divisible by 49. Does not depends upon the remainder. Does not depends upon this value. Remainder is always 0. 7 square into some integer. This value divisible by 49. Okay, so we check the remainder. To find the remainder, first we find this value. The remainder depends upon only this value. That means 2 of, please observe this value, 2 of 83 into 7 plus it is in the form of 49k. So this value does not depends upon, remainder does not depends upon that value. Here what is this value? 2 into 83 into 7. That means find this result and divide with 7, find the final value. Okay, that means that value is 83 into 14. What is the value of 83 into 14? 12. Next 32, 33, 83. This value is 2, 6, 11. 1162. This value is 1162. So divide 1162 with 7. What is that value? How many times? 1. Next 7. It is 4, 6, 6 into 7, 42, 42. So what is that value? Next how many? Sorry, we divide with 49. Sorry. We divide with 49, not 7. Divide this value with 49. 1162 divide with 49. Get what is the remainder. Okay, find the remainder. Next, fourth one. If 1 plus 2 plus 2 square plus so on, 2 power 1999 is divided by 5. Then the remainder is dash. Divided by 5, then the remainder is dash. In this case, this value is divided by 5. What is the remainder? So in this case, suppose it can be reduced into 5k form. What is the remainder? 0. 5k plus 1, remainder is 1. 5k plus 2, remainder is 2. 5k plus 3, remainder is 3. 5k plus 4, remainder is 4. So first we reduce this value into 5k plus something value. So what is the given value? 1 plus 2 square plus so on up to 2 power 1999. Observe these values. These are in the GP. How many terms are there? Except this one, 2 power 1, 2 power 2, 1999. That means 199 plus this value. Number of terms in this expansion is equal to 2000 terms. Okay. Plus A is equal to 1, R is equal to. What is the sum of the n terms in GP? A into R power n minus 1 by R minus 1. Okay. Here A means 1 into R means what is the value? 2 power 2000. 2 power 2000 minus 1 by 2 minus 1 means 1. Okay, this value is 2 power 2000 minus 1. After simplification, this value is equal to 2 power 2000 minus 1. This value can be reduced into 5k or 5k plus 1 or 5k plus 2 form. Here base is 2. This value can be reduced into 5 multiples or 5 terms. How we can reduce this value? Please observe this value. 2 square means what is the value? 2 square means 4. 4 can be reduced into 5 minus 1. Okay, please reduce that value. 2 power 2000 minus 1 is equal to 2 square whole power 1000 minus 1. Okay, 2 square means 4. 4 means 5 minus 1 whole power 1000 minus 1. It is in the form of x minus 1 whole power 100 or 1 minus x whole power 100. Okay, that means it can be reduced into 1 minus 5 whole power 1000 minus 1. Now this value is equal to, after expansion, it can be reduced into 1000 C1 minus 1000 C0, 1000 C1 into 5 plus so on, this value minus 1. Here please observe this value. 1000 C0 means 1 cancel. Here 5 square, 5 cube, so on, 5 power 1000. What is the common term? 5 into some integer. Please observe this value. Here 5 is the common term. 5 square, 5 cube, so on. 5 into some integer means it is in the form of 5k. 5k means what is the remainder? 0. Remainder is 0. Very, very important. Please note that value. This value is reduced into 5k form. So the remainder is 0. Next. Find the fractional part of 5 power 2000 by 8. Fractional part of, where this value denotes fractional part. In this case also we reduce this value. 5 power 200 can be reduced into 8k plus 1 or 8k plus 2 or 8k plus 3 so on by 8. This value is integer. So the fractional part depends upon only remainder. If it is in the form of 8k plus 1, fractional part is 1 by 8. If it is in the form of 8k plus 2, fractional part is 2 by 8. So this value can be reduced. 5 power 2000 can be reduced into base 8 or multiples of 8. 8 or multiples of 8. So first, what is the value? 5 power 200. It is the prime number, it is the composite number 8. Directly we cannot reduce this value into 8. But it can be reduced into multiples of 8. How it is possible? Please observe this value. This can be reduced into 5 square whole power 100. What is the value of 5 square? 25 whole power 100. 25 can be reduced into 1 plus 24 whole power 100. 24 is the multiple of 8. 8 into 1, 8. 8 into 2, 16. 8 into 3, 24. If the number is divisible by 24, that number must be divisible by 8. So it is a multiple of 8. Okay. So reduce this value into in this way. That means 100 C0 plus 100 C1 into 24 plus 100 C2 into 24 square plus so on infinite. So up to 100 C 100. Here what is this value? 1 plus. Here what is the common term? 24 into some integer. That means 8 into 3 into integer. That means it is in the form of 8k plus 1. Please observe this value. 8k plus 1. Therefore, fractional part of 5 power 200 by 8 is nothing but fractional part of 5k plus 1 by 8. 8k plus 1 by 8. Okay. That implies fractional part of k plus 1 by 8. Here k is integer. Does not depend upon this value. That is equal to 1 by 8. Very, very, very important. Very, very important. Please note that value. Fractional part depends upon the remainder. Remainder only 8k plus 1 or 8k plus 2 or 8k plus 3 or 8k plus 4 so on. If it is in 8k form, What is the fractional part? Remainder 0. 0 by something means 0. Fractional part is 0. Okay. Next, sixth one. Sixth question. The last digit of 7 power 100. The last digit of 7 power 100 is dash. First question. Second one. The last digit of 7 power 100. 2 digits. Sorry. Third one. The last 3 digits of. The last 4 digits of 7 power 100. The last digit of 7 power 100. Last 2, 3, 4, 5, so on. Okay. Here what is the problem? 7 power 100. 7 power 100, we find the last digit of this number. Suppose after expansion this number is in this way. Some value so on dash 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 2. What is the last digit? 2. Okay. These values are not necessary to find the last digit. So we reduce, suppose this equation can be reduced into some integer into 10 plus some value. The last digit in this case is 0. So last digit depends upon only this value. Okay. 10 into some integer plus k1. So last digit depends upon k1 only. K into 10, k into 100 plus k1. Here last 2 digits must be 0. So does not depends upon this value. Depends upon only k1. In this case we find the last digit. So the value can be reduced into 10 into some integer plus constant term. That depends upon, the last digit depends upon that constant term. Okay. Please note this value. 7 power 100. In this case base can be reduced into multiples of 10. Multiples of 10. 10 or multiples of 10. 10 is the composite number, 7 is the prime number. Directly cannot be reduced into 10. But it can be reduced into 7 square whole power 50. Please observe this value. 7 square means 49. 49 whole power 50 means 50 minus 1 whole power 50. Here the last digit is 50. 50 multiples are always, last digit is 0. Does not depends upon this 50. Okay. Please observe this value. Okay. 50 minus 1 whole power 50. That means 1 minus 50 whole power 50. Even power. Minus of 1 minus 50 whole power 50 means minus 1 whole power 50 means plus. After expansion it can be reduced into, please observe this value, 50 C0 minus 50 C1 into 50 power 1 plus 52 C2 into 50 square minus 1 50 C50 into 50 power 50. Okay. Here what is the 50 C0? 1 plus, what is the common term here? 50. 50 is the common term, minus 50 C1 plus 52 C2 into 50 plus 1. All of these values are integers, some integer. 1 plus 50 into k. That means 10 into 5 into k plus 1. Here last digit must be 0. Sorry, last digit must be 0 in this case. So last digit depends upon this value. What is the last digit? Only 1. Okay. Next, to find the last 2 digits, this base value can be converted into some constant into 10 square plus some number. In this case, what is the common term? 50 square is the common term. Suppose the 50 square is the common term. Next we get 50 square means 50 into 50. We get 2 zeros. 100 into something. Okay. In that way we can do this problem. Please observe this value also. What are the last 2 digits in this value? Last 2 digits in this value. Please observe this value. 50 C0, that means 1. Okay. Minus 50 C1 into 50 C1 means 50 into 50. 2500. Okay. 2500. Plus here what is the common term? 50 square is the common term. 50 square into some integer. Please observe this value. 50 square into integer means 2500 into some integer. Does not depends upon this value. Does not depends upon last 2 digits. Does not depends upon this value. Depends upon this value only. 1 minus 2500. But it is negative. But it is negative. Please observe this value. It can be converted into positive value. It can be converted into positive value. 1 minus 2500 means 2499 minus of. Here 2500 into k. That means plus 2500 plus 2500 into k minus 1. K is integer, k minus 1 is also integer. 2500 minus 2000 both are cancelled. What is this value? This value is nothing but 0, 1. 1. This value is nothing but 1. This value is last 2 digits must be 0, 0. Here 1 means 0, 1. Okay. Here what are the last 2 digits? 0, 1. Similarly, we find last 3 digits, 4 digits, 5 digits. Please observe this value. Very, very, very important. In this case, suppose the number is in this form. Suppose 10 square into k plus 5. Last digit is 0, 5. 10 square into k means last 2 digits must be 0. In this case, only units place is 5. That means it is 0, 5. By adding these values, we get last 2 digits are 0, 5. Okay. Suppose this value is minus 5. Last digits, please observe the number system. Each digit lies in between 0 to 9 only. Negative numbers are not appeared. Please observe that point. All are positive. 0, 1, 2, 3, so on 9. Suppose this is the negative value, we split in this way. That means 10 square into k means 100 into k. So 100 into k minus 1 plus 100 minus 5. What is this value? 95. So last 2 digits must be 95. Please observe that point. If it is a negative, we reduce this value in this form. Okay? Please note that value.